A rooted tree is a particular type of tree that is quite useful in applications. So consider the tree given on the left here. We know this is a tree because it is connected. No matter where you start, if you follow edges, you can reach your destination. For example, if I start at E, I can reach D. Also, it does not have a cycle. When I follow that path to D, I have no way to return to my starting point without repeating an edge. So when we have a tree like this, it's very cluttered, and it would be nice if it could be redrawn in some more aesthetically pleasing way. And sometimes that aesthetically pleasing way actually has a physical meaning. So in this particular case, I have taken the tree on the left and I've redrawn it. And I've done it by putting G at the top. Then from G, I have two directions I can go. I can move towards F and then E, or from F, I could go to A, B, C, or going all the way back to that G, I could have gone to H and then D, I, J. The graph on the right is definitely easier to look at. And as I said, it often has some physical meaning. Now, when we can draw the graph in this way, where it starts at some top and it only works its way down, then we call it a rooted tree. And in a rooted tree, the root is the thing that goes at the top. Now, when you start at the top, you can work your way down. Imagine this were a family tree. Well, if this were a family tree and I looked at Great-Grandpa G, then it would show Great-Grandpa G's children. So G has two children, F and H. Or I could look somewhere else, like A. A has two children, B and C. What if I'm looking at one of these vertices in the family tree, like A, and I say, hey, tell me a parent. Well, parent appears higher than you in the family tree. So F is the parent of A. I could also ask, who are the ancestors? Well, from A, F is an ancestor, and then you can go up further to G. So there are two ancestors of A here. If my starting point were further down the tree, like C, then there would be lots of ancestors, A, F, and G. Next, we have descendants, just the opposite of ancestors. For example, if you start with F, there are three descendants, the two children, and you could call these grandchildren if you wanted. So there are four descendants of F. Finally, let's talk about some language describing where something appears on this tree. So if we think of Great-Grandpa G as being the original member of the family, then I might want to call that part level 0, like the starting point. And then G has two kids. Well, the kids would be level 1 because it's one level down our family tree. Then level 2, and finally level 3. If G was this ancestor, then F would be the child, A would be the grandchild, and these would be the great-grandchildren. So level 3 indicates that we've gone all the way down to great-grandchildren. Okay, so then what do we have? Well, we also have level of a vertex. So looking at this, so we have the level of the vertex, and looking at this, let's say we pick D. Well, looking across here, D is level 2. So the level of the vertex is how far down you had to go from the root. Finally, our last term we're going to have for rooted trees is the depth. And the depth just tells you how far down the tree you go. So the depth of this tree is 3, because if I started at G and I worked my way down, it would take me 3 steps.